Let's have a look at the equations of circles and ellipses. We have a circle with a point xy on the circumference. That means the length at the bottom of this right triangle here is x, and the side length there is y, and the radius there, the hypotenuse, is r. So we can apply Pythagoras' theorem to get the equation of that circle. X squared plus y squared equals r squared. So that's the equation of a circle with the center at the origin and the radius r. And we'll note that this equation is a relation. It's not a function because any x value will have not just one value of y, but two values of y. Let's move the circle now so its center is at xc,yc. Then the radius is still r, and we can apply Pythagoras' theorem to this right triangle. The hypotenuse is r. This length here is x minus xc, so it's x there less this much. And similarly, in the triangle we have y minus yc. So applying Pythagoras' theorem, we will get that equation for the equation of the circle with the center at xc,yc and the radius of r. So in this example, we have to find the equation of a circle given the center and radius. So we'll use that form that we've just derived, and we'll substitute in the values that we know. The center is at minus 3, 5, so that means the xc is minus 3. We're subtracting that, so it becomes plus 3. And the yc is 5. The radius is 3 root 2. So let's square that. 3 squared is 9. Root 2 squared is 2. 9 2s are 18. So that gives us the equation of the circle that we're after. In this example, we're given the equation of the circle, and we want to find the center and radius of that circle. So we need to put it in that completed square form. We'll start off by putting all the x squared and x terms together and the y squared and the y term together there. And then we can take 2 out as a common factor out of the two first terms. And likewise with the y squared and y terms, we'll take the 2 out as a common factor. And the 1 can go over to the other side of the equation. Now we need to complete the square both for x and y. So we need to add some amount here. And it's always half of this number here and squared. So half of 2 is 1 squared. And likewise here we need to add half of 4 is 2 and square it. And so we've added a 2 times 1 there is 2. And a 2 times 4 is 8, which we add on both sides of that equation. Now we've completed the square here. We've got our x minus 1 all squared, and we have our x minus 2 squared there. And adding the right hand side, we'll get 11. Now we need to divide both sides by 2, and now we've got it in that form where we've got our center of our circle is given by 1, 2, and our radius is given by the square root of 11 over 2. Moving on to the ellipse now. The ellipse is defined as the locus of points where the sum of the distances from two fixed points is constant. So if we look at this first point here, we can once again make up a right angled triangle. We can see the height of that triangle is y, and the length of the base there is x minus the c. So that distance is x minus c all squared plus y squared. That gives us a hypotenuse in that triangle. Moving over to the other side, once again we'll construct a right angled triangle. Its height is again y, and we can get that distance as being x plus c. So that distance plus the other distance has to be some constant d, and that gives us the equation of an ellipse. Now we can simplify that down, and it comes out to be in this simpler form. We won't go through the proof of that in this video, but you can refer to page 582 of the Washington text to see a proof of that. And that's the equation of an ellipse there. That's a relation because, once again, our values of x will have two values of y. So there's our equation. We can find the x-intercepts by putting y equals 0, and that'll give us x is equal to positive or minus a. And likewise, we can find the y-intercepts by putting x equals 0, and then our y-intercepts will be plus b or minus b. Notice that the length of the major axis there is 2a, and the length of the minor axis is 2b. So in this example, we want to sketch the graph given the equation. So we can see that our value of a is 3. That's because we've got 9 there. Square root of 9 is 3. And the value of b there is 5. So that means our x-intercepts will be plus 3 and minus 3. And our y-intercepts will be plus 5 and minus 5. So all we've got to do now is join those up in a smooth curve, and that'll give us our ellipse. We can find other points in between there by putting x equaling to values such as 1 and 2. So we've seen that the equation of a circle centre xc, yc with radius r is as given, and when the centre is at the origin, the equation simplifies to x squared plus y squared equals r squared. An ellipse with the centre at the origin has the equation x squared over a squared plus y squared over b squared equals 1.